Hey, it's Jeff here, and I'm going to do some live coding on my Lizard game. Today I'm going to try to add water ripples. Let me show you where that's going to go. So this here is the game so far. You hear this little dinosaur right in the middle walking around, and gotten myself stuck. Start off with a bug. Okay, that was a rough start. We've got some stories to fix that. So if you look carefully, you'll kind of see a little trail behind me everywhere I go. It's subtle, but it's there. When I go through water, if you look really close, it just darkens a little bit in the water, but it's pretty hard to see. And so I want to make that look a little bit better and even have a ripple effect. And the way that we're going to do that is we're going to use a technique called cellular automata, which is taking a cell in this grid layout and looking at its neighbors in order to decide what to do with it. And that's the technique I use for the lava, which you see spreading across the screen from the right. So we're going to apply that to the water ripples. Let me switch over to my code. And let's get started. The place that I deal with the effects on the terrain is in a component, and that component is called displacement. And I have a displacement system. I'm using ECS pattern right here. And I have two components that get affected by this, deplaced and deplaceable. Deplaceable is going to be added to a terrain tile, and it means that it can be deplaced, and it's got a heal rate that is different based on each terrain type. And then deplaced means that it's actually been deplaced and it has an amount, and that amount gets reduced every tick of the query system or the displacement system. Based on this query, everything that has these two components we just looked at is going to loop through them and decrement the displaced amount by the heal rate until it's no longer deplaced. And then this gets used primarily in the drawing part of the game, where if it has a deplaced component on it, then it renders it differently. In this case, it darkens it. And so the very first thing that I want to do is, instead of darkening, I'd like to lighten it. And I'm going to make an extra function here called brighten. And let's see if we can just have it auto-complete this for me. Take a look at that in a second. Let's do something like that. Does this look right? This is using the rot.js library, and multiply. I don't know if that works. I don't think it does. I think we actually want to use add here, but what's going on? What is this doing? Funny how it decided to do it like that instead of, oh, I guess that's what I'm going to pair to. Okay. Let's come back here and just use brighten for a second and see if that works any differently. We got a bug. Brighten is not defined. Yeah, that's right. I need to import it. Okay. One more time. Got a bug where if I start in water, I can't move, so I'm gonna have to fix that. But we're moving around. Is that brightening? Look like it's brighter. I don't know if it looks like it's brighter. let's try doing it by full one and see what happens here. Yeah, that's kind of what I suspected. So just real quickly here for brighten, multiply is always going to be a fraction of whatever the color is. So we actually want to do add, and the amount that we're adding is going to be whatever the current color is, and we're going to add whatever this added amount is. We don't want to go over the brightest amount, so we should clamp it. Maybe that won't matter yet. And what else? We don't. I'm gonna change this one to look more like what we have up here. So much for the automatic rewrite. Let's just try it like this. So as long as we're adding, this will be fine. Debating if I want to clamp it or not. Let's see what happens. Oh yeah, there we go. Now we're brightening. That looks great. That looks really nice. Let's go through some water. There you go. Now we got a nice trail of water behind us. Yeah, like that. So I want to keep it dark for the terrain, but I like it for the water. And the next thing that we're going to do is I don't just want a path right behind me for the water, but I actually want a ripple. And we'll see how that works. So change that back to darken and say right here of where's my terrain? I need to find out what the type of terrain is. Entity is instance of water. Then brighten it, and we'll do like 0.4 maybe. Otherwise, darken it by 0.7. And then what am I? Okay. And then why do I have one of these right here? That's how you do ternaries in JavaScript. Do we have some water nearby? So that's darkening nicely, which is good. Here's some water, and that's brightening. Perfect. So already, I like that better. Now let's go for the rippling effect part of this. And I'm not sure if this is going to work out the way that I imagine it looking, but hopefully it'll work and it'll look nice. So back over in our system, displacement system, this will run every tick, and what I want to do is find the tile that is currently being iterated over, find its neighbors, if they're water, and if they don't already have displacement on them, add it, but at a decayed rate. So let's do that here. And this will only do that if, well, yeah, let's see. So, current XY is going to be, I have to do a whole lookup here. Let's see if it knows how to do the lookup here. That's not at all how it works. So I need sort of an awkward place to be able to do lookups because my system only gets the world. The world doesn't store XY coordinates, unfortunately. So what I need to do is somehow include the means of lookup through here. So let's go back to the level, and this was a terrain ECS world. This is where this gets set. This gets created here, and oh, I do pass the level into it. So I have access through it that way. Okay, excellent. So what we can do is world.level, and then I have a couple different indexes of various entity types. And the one that is on for tracks terrain is the map. And does it work this way? I forget what my API is. Map is the map of all the terrain pieces. At will return the terrain, but at an XY, which I still don't have. So I think I have get. Nope. Do I have something that gets by ID? Let me go look at my world map and see if I've made one of these that can do a get by ID. I don't, because I only recently added IDs. My map for dinosaurs, which looks like this, has a get by ID, and I track IDs right here. So I think I'm going to have to add a similar means for this one as well. I wish that I had them tracked by ECS, but I don't. All right, so let's go add the IDs here. So IDs, we're going to add a map of IDs. This is going to go to terrain, and over here in our constructor, we're going to track those IDs, and we're going to add a get by ID, which is going to return a terrain. Oh, I already have a get. Wait a second here. Where's my other get? Oh, I have a get by bounds. Okay. So what I'll do is I'll just call this one get by ID. And I need to make sure that I keep everything in sync. So when I do an add, I have an add in this one, my terrain index has a little bit of a different API than my dinosaur index. How do I, oh, set, I just call it set. Let's just make sure that it should be fine. We're gonna always add the ID, and in this case it is terrain. Same for that. Okay. Now we are tracking them. I need to clean them up as well on remove and set. Okay, now we've got tracking from an index from ID to terrain. So now we should be able to do everything that we need. So back in my displacement system, now I can do get by ID and pass in my ID, and get back my terrain that I care about and get the XY of it. And this is going to be EID. Now I know what the current XY is, and now I can get its neighbors. Let's let it auto-complete that for me. That seems about right. XY is an XY type, and the XY type has a plus to add to your basic vector, and this is just getting all the neighbors in all directions. So got up, down, left, right. Now for each neighbor, I want to just do what I had said before. So that's not how that works, but if it's an instance of water, and if it doesn't have, let's see, has component, or what's this? I think I'm pretty sure this, my ECS system, yeah, has component of the world, the component being deplaced, it's not already deplaced, and the EID. So if it's water and if it doesn't already have it, then this is not really what we need. We just want to add component from the world. We want to add displaced. And now it's displaced, and then we want to set the displaced amount of that EID to something, and 100 is what they normally get set at. But what I'm thinking is that we should set it to something less than it so that the ripples decay over time. So let's do something like the current amount of the current one divided by 2. So displaced, not displaced, EID, and this is actually supposed to be the neighbor dot. What is the neighbor here? Neighbors are, oh, they're XYZ coordinates. So I actually need this to be neighbor ID is going to be, that's not how that works. Or no, that we can use the same thing we just built. Yeah, world level map get by, or no, actually I have a get from, or I have an at that takes an XY and returns my dinosaur or my terrain that's there. And for now, we'll just assume that it's always going to be there. And then this one is the neighbor ID. And so is this one. And so is this one. Do I not know how to spell neighbor? I don't know how to spell neighbor. That's not how you do integer division in JavaScript, so I need to floor this. And the reason I need to floor it is because this is an int 8. I'm not sure what happens if it would be float, but it would mess things up. Okay, I think that does what we want. So find everything around the current one for each of those ones. If it is a, you know what, let me do it this way. Let me make this be one of these, and let me do if neighbor ID. And we got one of these. Why is this? Getting this. If it's one of these, yeah, now we don't have to worry if it doesn't exist. So find all the neighbors. Based on that ID, make sure that we have one there, which now that we've done that, we don't need this. Oh, sorry, this is the get. You know what I'm gonna do? I'm gonna change this to like that. And then I could do neighbor ID, or no, neighbor is that, and then everywhere here this way. Okay, that's a little better, and one more over here. Okay, now we're good. So these are all neighbor XYs, which is to keep myself from getting confused later XYs, and this is going to be neighbor XY. Okay, there we go. Go through all the XYs, find what the entity is, make sure it's water, and make sure it doesn't already have a component on it. Add the displaced component and set it to half of the current component. Let's see if that worked. You ready? Gotta get down to some water. So far, walking through grass and everything works the same way it did. And here's the moment of truth. Whoa, something weird happened. Every single one of these got really bright. And check out my frame rate. Ooh, it's really bad. What happened? Yeah, so I'm pretty sure that somehow the cellular automata has spread throughout the entire water region. You see how like right by the shore is not as bright as everywhere else? I think I've spread across the entirety of the water. Yeah, look at that. Like everything turned white. So we're spreading too far. The question is why? So let's review this again. This is going through every one that is displaced. If it's displaced, also this one, if it gets reduced past 0, then it would be removed. It would be removed from that component would be removed, but it will still hit its neighbors. But I had thought that by then its neighbors would already have a displaced component on them, and so it wouldn't matter that this would be a no-op. So the question is, why is this not being a no-op? And let's take a look. I have a debugger in here, so let me click on one of these, and you can see here what components it has on it. So it is deplaceable, and it's still has deplaced, and it's got a deplaced of 0. And here, this should be iterating through that, and if the deplaced is 0 or less, it should be removing it. I wonder if it gets removed and the ones right next to it add it back to it. I bet all of these are deplaced of 0. So I don't know if this will make a difference. Let's give it a shot though. We gotta fix that bug of starting in water there. Okay, oh, there we go. Oh, check it out, it's working. I'm suddenly stuck. I'm suddenly stuck, but look at this. This is interesting. There's like these ripples moving through here. One thing that I want to do is in the level where I set the deplaceable component, if it's water, we set deplaceable, and we want this heal rate to be much faster, because the faster it heals, the less long it'll be around, meaning the less persistent the effect will be. Where's some water? This is a weird map. Let me go find a map where I'm near water. Here we go. Okay, boom, we're in water. Look at those ripples. Yeah. That is definitely rippling. Let's pause it right here and take a look at it. So, first of all, this is pretty cool that we've got a ripple going on here that looks nice. I think it achieves kind of what I wanted. It's a little more widespread than what I wanted, so I'm going to look through here. See, these don't have the deplaceable on there anymore, but this one does. It's at 40. This is at 20. We've got one at 60. I am wondering why we have ones that are so much higher than others. I like the effect, but I'm going to go try to debug why it might look different, or why it's so intense. So back to here. This is the part where I thought it would decrease it. And the part that adds the very first one is in the movement system. Oh, movement system actually calls out to the move, and the move figures out, here it is, if it should do some deplacing, and it starts with a deplacement of 100. So that's where the original one gets set, and then when we spread it, we're doing half of it. So let's try just like dividing it by 4 maybe, and see if that makes a smaller impact. Got some nice little pools here. So what I'm seeing right now is that the ripple effect looks pretty nice to me, but the original trail is lasting a lot longer than I want it to. And that's because it starts at 100. And let's see, are these ones even going away right here? How much are these? That's weird. Why are those not going away? And then if they don't go away, this will just keep spreading, is the thing. A lot of them are not going away. Oh, look at this up here. It sort of goes away and then it sort of gets added. That's interesting. So this kind of effect of this sort of organic growing of a pattern is what you often notice in cellular automata, and it can be a little tricky to control the way you want it because it's kind of recursive. Like when I add one, it will pack the ones around it, and those ones pack the ones around it as well. And so I have to really tie it down, figure out what was where some of them are spreading more than I want. So it's doable, but it's going to take a little bit of debugging. I think that I'll stop here and finesse it on my own. But there you go. That was basically adding ripples to our water with cellular automata and ACS.